Hello, everyone. Welcome to our first lecture on intelligent systems. So in this first lecture, I'm going to give you an introduction on several of the topics that we are going to cover in the course. First, a general introduction and motivation, and then I'll talk about 3 technologies that we'll cover in more detail throughout the course. The first one is called text mining, application of natural language processing. The second one, knowledge graphs. And then I will talk about intelligent agents. So the goal is that after this introductory lecture, you know some of the concepts that we'll talk about, and you also have a better idea if this course is really what you are looking for. So let's start with a first motivation. And here I have a somewhat older graphic. It's a couple of years old that shows how much content is being created in just 1 minute. So if you look on any online resource, you look at tweets, web pages, YouTube videos, and so on, you can see there is a huge amount of content that's created. And again, this is a couple of years old. By now, this is probably a lot larger than what's shown here. But the point is, if you look at the volume of content, of data, of information that's created, it's basically impossible for any human to keep up with all the new information, all the new knowledge. Now, just the amount of videos on YouTube that's uploaded in 1 minute is now probably more than you can view in your entire lifetime. And similarly for information published on web pages as electronic books, emails, tweets, and so on. It's basically impossible now to keep up with the rapidly increasing amount of knowledge. So we need some kind of technology that helps us to get through this huge amount of content. So if you look at this from an application perspective, and here application I mentioned in the introduction to the course, we're going to look at applications of AI. We're not going to look at things like gaming. If you look at a knowledge worker who has to work on a task, the old fashioned approach is that this knowledge worker interacts directly with some documents. Now, it could be electronic documents on an online word processor, emails, and so on. Knowledge worker is an established term in industry, somebody who has to do some kind of intellectual task. So basically anything that has to do with science, engineering, but also business is termed as a knowledge worker. So if you put these 2 images in context, you can see that a knowledge worker, for example, a scientist working on a new drug, or a business person who wants to analyze information from government and industry and so on, is going to have a hard time to keep up with manually going through documents. So the goal is to make use of modern techniques, and I explained also in the course outline introduction, intelligent systems for us means applying some kind of artificial intelligence technique. So here in this course, we are going to look at a few of those techniques. We are looking at text mining, we are looking at knowledge graphs, personalization, recommender systems, and intelligent agents. And I'll introduce a few of those in the next couple of slides. So let's start with a technique that you are all familiar with, something like a search in a document, like a full text search. What you can do very easily is simply index your documents that you have. Let's say you're a knowledge worker, you want to index all the business documents that you have, all the memos, all the emails, all the guidelines. And then there are a number of libraries. Some of those we'll talk about later in the course for indexing, like open source Apache Lucene library, search servers like Solr or Elasticsearch. So this is something that's solved. You can just index all the documents, and then you can already solve a certain task using this automated approach. If somebody gives you the task, you indexed all the company documents, all the business documents, tens or hundreds of thousands of documents, and you have to find all occurrences of a person, Steve Jobs. Then you just go to the search engine and it will very quickly find this information in all the documents. Okay, great, right? So you've solved the task that you were given. You have hundreds of thousands of documents. Somebody tasked you with finding out everything, all the documents and the sentences in the documents mentioning Steve Jobs. You're ready to go home, but then somebody comes and gives you another task. And now you have to find all the persons mentioned in the documents. So now what do? Well, you cannot just do a search for person, because it's not about finding the occurrences of the word person. It's about finding concrete persons like Steve Jobs, for example. So now you have a problem. You can go back to manually reading all these documents and finding out all the occurrences of a person, but then you're going to stay, you're not going to get home by 5 p.m. You're going to work for a couple of months, probably, if it's a large number of documents. So that would just not work. So you cannot just rely on search. You need something else. You need an AI technique that's called information extraction. And that's a specific subtask of text mining, which is, as I mentioned, an application of natural language processing. So natural language processing itself is a subdiscipline of artificial intelligence, and it's about using a number of different techniques to work with content written in a natural language. So in NLP, we deal with content written in English, French, Spanish, German, Italian, Chinese, whatever you have, and then you do some concrete task with it. You'll see later on in the course, we'll talk about how to implement this. Typically, this is done with some kind of so-called NLP pipeline, meaning you have a number of processing steps that go through the document and then extract the information that you want from the document. So now we can already change this architecture that we had before. Instead of the knowledge worker going through the documents by him or herself, we now put in an NLP pipeline that can process these documents and then, for example, find out every mention of a person. And then the knowledge worker will interact with this AI, with this NLP pipeline, and then automatically gets the results. In this case, we were interested in all the mentions of a person. So text mining is one of the tasks that we are going to cover in this course. It is an application of natural language processing, and there are courses on NLP, and NLP is also covered as part of the Introduction to AI course. But here we are focusing more on the application of NLP. So we will go less into the algorithms and details, how they work. We'll look more at the applications of NLP. Essentially, if you want to implement something like this, you can either implement this yourself. There are a number of tools and libraries that are very mature, open source. We'll look at some of them and also do lab experiments with NLP. The other choice is that you use a SaaS approach. So you have a online service provider. Amazon, for example, has a service called Comprehend. Another service that's very well known is Refinitiv. And then you have a web API for various tasks. But the goal is, in this specific case here, we are giving either our own tool or a SaaS platform the text that we want to have analyzed. And then we can have it analyzed for various criteria. So here, for example, you can see I wanted to have all the persons detected in the document. So in this case, I could just, after processing, select the person entity, and then it will highlight, in this case, an green all the persons that it found. This also works with other entities. So for example, you might want to find dates or organizations or what exactly you are interested in depending on the domain. For example, here you see various locations and so on. A bit more on how this works. I mentioned the concept of the NLP pipeline. So in this case, we have a pipeline for information extraction. So we want to extract information like a person, a location, an organization, a date, and so on. So technically, this is not done in one step. This is split up into multiple processing steps, and this is why it's called a pipeline. So you start, here's an example for a pipeline that produced the results that you've seen on the previous slide. So for example, we are, our first step is just cleaning up any previous processing steps. Then the text is tokenized, so meaning an input sentence like here is split into individual words, so-called tokens. Then the tokens are indexed with a so-called gazetteer. For example, these are lists of countries, of names, and so on. So they will get additional markup. Then the text will be split up into sentences. Very often for many tasks, you have to know where one sentence begins and the next sentence ends. We are analyzing it for part of speech. This will tell us if a word is a verb, a noun, an adjective, an adverb, and so on. And then there are steps that combine all of these previous information and look for complex entities. So an entity is something like a person, a location, and so on. So you can see a little bit of this here. Each word here was split up into a token. Some of these were detected in lookup lists. So like lists for names or for specific locations, like a list of all countries. This is something you can just feed into a system like this. And then later on, the rules or the steps that are processed here will find entities like organizations or persons. So later on in the course, we'll talk about this in more detail and you'll implement something like this yourself. I mentioned the other approach is not implementing it yourself, but relying on existing SaaS web services. So there is a number of companies that offer various text mining, text analysis tasks. I mentioned Amazon. I'll show an example for this later. Another one that's very well known, it's Refinitiv. It's actually a lot better known under its old name, which was OpenCalle, which was a sub-branch of Thomson Reuters. So the same company that owns the Reuters newswire. But about a year ago or 18 months ago or so, they were spun out into their own startup. And then they rebranded themselves as Refinitiv. But if you look for OpenCalle, you'll find a lot more references for the technique. So if you're interested, have a look at their webpage. And again, we'll cover this topic in more details later. There are also complete text mining systems that you can look at online. I'll show you one of these here. So this is a tool that was developed by a research institute funded by the European Commission. It's the European Media Monitor. And essentially, it monitors news articles and other news sources, originally with a focus on Europe, but then extended to pretty much any online news source. So it will, in real time, scan news sources in more than 70 languages, updated continuously, tens of thousands of sources, and then extract all the time what is currently going on in the world. So on the main page, when you open it, you'll see it lists the top 10 stories and how they developed in the last couple of hours. So there's a story that Pfizer is scaling back vaccine delivery, story about the Justice Department, So you can see which stories are currently developing and which story is sort of flattening out or not as important anymore. We also list then in detail the stories. So it will group different articles under one heading. It can find out what the stories for the last 24 hours were, what the major events in those stories were. And then you can drill down in what you're interested in. So there are various ways of filtering it. Of course, this being a EU-funded tool, there is a lot of specific information about the European Union, about policy areas, about themes that are interesting, like food safety, crime, natural disasters, terrorist attacks, and so on. But it's not just limited to Europe, it's basically covering the whole world. And then if you pick a story, like this one here, Mike Pence calls Kamala Harris to offer congratulations. Again, you see the details about the story, what exactly happened, what articles were published by various sources and in what country. So you can see most of these here are in the US, but there are some in the UK and in other places. And you can see which location is involved in the story, and you see the persons that are mentioned there. So not surprisingly, in this article, it's Kamala Harris, but you also find Donald Trump. Well, Donald Trump is everywhere, but let's look at Kamala Harris. And then you can see a page for this person. This is what I just mentioned earlier. One of the things that the system can do is extract all the occurrence of a specific person, like in this case here, Kamala Harris. And not only will it find the person, it will also look at first, what is this person quoted as saying in all these news articles? And then second, what did other people say about this person? So here you can see that was one of the original ideas why this was funded and why politicians gave money to fund this system. Obviously, politicians are interested in what other people say about them and also what is quoted as them having said and then appears in the press in many different countries. And even for something like Europe, you have dozens of languages, tens of thousands of news sources. It would be impossible to keep track of this manually, even if you pay hundreds of people to do this all the time. So here you can see that on this page, this is all automatically generated. Everything that this person said is extracted and then shown here. And you can see this is not limited to English, because it covers so many news sources. You see information in English, in German, in Spanish, and in all kinds of other languages. And then you can further drill down where exactly this was said. You come back to the news source, what date and time this was said, and so on. And here other information. For example, which other persons are mentioned in contact with this person the most, and so on. So this is a very interesting and fun system to play around with. And what you can see is that things like extracting a person is not really a simple task. Going back to the slides. Looks a little bit different because it's an older screenshot I took, but you can see that it's not, even if you want to know everything about this person here, in this case, Angela Merkel, it's not as easy as just looking for this exact string, because the same person, the same entity is going to appear in a very different writing in different news sources, depending on the language. So you can see here that in German, in Dutch, in English, in Russian, in Spanish, in Arabic, this person is going to have a very different appearance. And in addition, sometimes the person appears with a title. So there is a number of titles also automatically extracted. So this is actually finding persons is a challenging task, especially if you do it across multiple languages. A Another feature, this is part of the same system. I can also just briefly show this to you. So that's this Medisys system. It's developed by the same research institute and basically uses the same technology, but instead of looking for people and organizations and political topics, it is looking for medical related events. So things like information related to diseases, but also information for bioterrorism, attacks, food security, safety, vaccination, medical devices, and so on. So one of the interesting things here is, let's say there is a new outbreak, like for one year ago, COVID, or something related to a food issue, then very often this might appear earlier in local news and news sources than it appears in official government communications. So with a system like this, you can track all of this information in real time around the world and then look for specific information and then see, keep an eye on what is going to happen in a specific discipline. And like for the news, you can look for the most active topics that currently appear somewhere. So not surprisingly, respiratory symptoms is currently the most active, but there are also various other information located with different countries. And then you can again further drill down and see what the possible source of this is and react to it. So you can see how incredibly useful and powerful these automated text analysis systems, these text mining systems can be. And there are a lot more examples for applications of text mining. So roughly around the middle of the course, when we start looking into natural language processing, we'll also cover in at least one lecture how to build systems like this. Another topic that we're going to cover roughly after the first third of the course, we will come to so-called recommender systems and then related techniques like personalization and collaborative filtering. That's again a technology that's related to AI that is implemented in numerous systems. All of you know an example like an e-commerce website. When you go to a website like this and you open it and you have used the website before, then it's not just going to sit there and show an empty screen. It's going to actively recommend something to you. So based on several information that are available, it will give you recommendations based on your past purchases. And it will also look at other people, what they have bought, and then sort of try to match what people with a similar profile have bought, but you didn't buy. So that's the idea of collaborative filtering. Let's say I bought 3 books, another person bought 3 books, and there's an overlap of 2, then it can recommend the third book to the other person. So these recommender systems, they are very important for especially e-commerce, but also for many other applications. And we'll look a little bit on how they work. We learn some of the underlying techniques like vector space representations and have some lab experiments on how to implement systems like this. Somewhat related to it in the sense that it's very often used in e-commerce is the idea of sentiment analysis, also often known as opinion mining. The general goal is here that you want to analyze information about a product or a service. If a person posts a review on an e-commerce website or writes a story about it on Instagram, on Twitter, the company would like to know what other people expressed about their service or their product. So not only do you want to find this information, you also want to automatically rate it. You want to find out, was something good or bad said about my product? And again, this is why this became commercially very interesting, with increasing number of online reviews on websites like Amazon and so on. It became really important for companies to keep track of all these opinions. If somebody has a negative review, this can have a bad impact on the sales of the product. Not even talking about fake reviews, which is a somewhat different topic. But again, this is something that's too hard to do manually. You cannot have a whole team in a company just browsing all the different e-commerce websites and keeping track of the reviews that were posted about your product and all the websites that review it and talk about your service and so on. So this became commercially interesting because you now can have automated services that go through all of these sources, e-commerce websites, news websites, social sites like Twitter, Facebook, and so on. And then a company can be alerted about something was just mentioned about your product and it was good, medium, bad. And then very often you see on e-commerce websites, and then often you see on these e-commerce websites that somebody responds, typically with some canned response to all of the questions, but you can see that somebody discovered that something was mentioned and posts an answer to it. So for a task like this, again, you could implement it yourself, but there are various online APIs that you can use. For example, there is one as part of the Amazon Comprehend API. And the simplest version is that it just analyzes the sentiment of the person. So for example, here, a person posted a review about a pair of shoes. I ordered a small and expected it to fit just right, but it was a little bit more like a medium large, great quality, and so on. So in this case here, you can see it was automatically rated as being somewhat mixed with a bit more positive and a bit less negative score. That's sort of the simplest version of sentiment analysis. You can also have a more in detail analysis that would try to find out which feature of the product was rated good or bad. But yeah, in the simplest version, you just have this kind of aggregate rating. Of course, this can also go wrong, and especially when AI goes wrong, this is when you see it in the news. A bit over a year ago, this article came up in various news sources where it involved WestJet, and it automatically analyzed the customer's feedback on the service. And I don't remember exactly what the customer said, but it was very enthusiastic. She was blown away and about the service, and it was outrageously good, and a couple more of these adjectives. And the AI completely misclassified and suggested to the happy customer that please, with these opinions, maybe call this suicide prevention hotline and talk to them. So this is a common theme that we'll see later on. AI, the techniques behind them, they can go wrong with especially something as complicated as natural language. So it's really not foolproof, and you have to manage these risks and be aware when you implement systems what can go wrong. This can be entertaining, like in this case, but it can also have very negative consequences because more and more of our daily lives and the businesses using AI for various techniques. And then it becomes very critical when these AIs go wrong and have, for example, a bias based on their training. Again, there was an example that came up in the news a while ago where Amazon worked on an AI engine that looks at resumes, at CVs that were sent in from people in order to find promising candidates to work for the company. Yeah, again, that's a lot of work, especially for a big company like Amazon. They get, I don't know, thousands of resumes every day, maybe even more. And it's just, for a human person, way too much work to filter and analyze them all manually. So they wanted to have an AI that does sort of a first filtering and classification step, finds good candidates, for example, matching candidates with people that already work there and have similar profiles and that worked out very well, and look at other features. But then in testing, it came out that this engine was very biased against women for various reasons. We'll talk about bias a little bit more in the course, but basically when you have these AI systems rely on training data, on examples that you feed them in, and then they learn from these previous examples. And in this case, typical for a tech company, the majority of the people working there were male. So the system by itself learned it must be better to employ male candidates than female candidates. And you'll later understand a bit better that this is not something you can easily fix, because it's something that the system learns based on the data you feed it in. So essentially, they didn't really have any choice. So essentially, they didn't really have any other choice than to scrap the whole project and start over. Okay, so to summarize what we've covered in this first aspect, the key phrase that you very often hear these days, data is the new oil. For businesses, for companies, for organizations, research institutes, it's the data, the information they have is essential for their work and for their success. And a lot of this data is in the form of documents, meaning in form of natural language documents. Think about all the product descriptions, inventions, technical solutions, techniques, experiences of the workforce, insights, and so on. And this is way more information than a human could possibly analyze. So AI techniques, intelligent systems, in this case, NLP and text mining, can help for individuals and for organizations to unlock all of this knowledge that is already there. If you want to do this in practice, in business, you need to have some kind of business vision. You want to know what exactly you are looking for. This is nowadays the much harder step than implementing it, because you'll learn how to do this later on in the course. You'll see the technology for at least this kind of intelligent system is very mature. This has been around for more than a decade. There are very good, robust open source libraries, and you can easily implement a system like this. Of course, the exact task that you want to solve can be more or less difficult, but in practice, it's a lot more challenging to develop the corresponding business aspect of it. And for this technique, as well as for all the others that we cover later in this course, because it's now adapted more and more in business and industry, there is an increasing number of legal and ethical concerns, because these AIs make automated decisions. They decide if you get a credit. At one point, they might decide if you can register for a course or get admitted to a university or get a job. So if this is handled by more and more AIs, it becomes very critical that we know, are these AIs ethical? Are they responsible? Can they explain the decision? If you want to challenge them, you say, okay, bank, you didn't give me the mortgage or the credit that I asked for, why not? Now there are legal frameworks being put into place that the AI has to explain the reasoning. The bank cannot just say, sorry, AI said no money for you. It has to give an actual explanation. So in practice, applying AI has sort of moved from this research field it was until the early 2000s into the big open business world with more and more challenges. So much for the first part of the introduction. As you'll see, I'll always split the videos into smaller segments. And for the next segment, I'm going to start a new video. See you then.